2,000 years ago, there was a Roman philosopher called Seneca. He humbly wrote the following: "There will come a time when our descendants will be amazed that we did not know things that are so plain to them. Many discoveries are reserved for ages still to come, but memories of us who have been effaced." The extent of our knowledge is bounded by the extent of our reach. That's why we go to space. And any spacefaring species like us has to face 7 barriers to go deep into space. The first 3 are already behind us. We are working on the next 2. And the last 2 will be our future work, which will probably take thousands of years. Barrier 1, that was gravity. Going to space was hard, long story, but we finally broke the shackle with Sputnik and Explorer 1. The second barrier was human physiology. An astronaut consumes about 2 metric tons of oxygen, water, and food per year, and it cannot be a one-way trip unless she or he desires. Right? That's why we use robots, right? As a matter of fact, the vast majority of our knowledge about the solar system was brought by robotic explorers, like Maven, right? And barrier 3, that's controllability. Early spacecraft like Explorer 1 was merely a flying sensor, right, which simply transmitted the analog readings to a sensor continuously, and that was it. No brain, no remote control. The solution was brought about by onboard digital computer, which enabled the spacecraft to receive commands from the Earth and execute them. So now the spacecraft become an avatar of the humans. So with these 3 barriers removed now, we have completed the basic reconnaissance of the all 8 planets in the solar system and many of their moons. However, there are still so many fascinating worlds in the solar system that are waiting to be explored in depth, right? Psyche is one. And here's another one. If you remember from Shannon's presentation, Enceladus. Remember his name, because I'm going to visit again later on. Enceladus is a small moon of Saturn, completely covered by ice, below which there is a global subsurface ocean of liquid water. Is there something living in there, in this ocean? To answer such an intriguing question, we got to overcome the next 2 barriers. Barrier number 4, environmental uncertainty. You never know what could happen to your spacecraft. For example, our Mars rovers got stuck in sand a couple of times quite unexpectedly. And the 5th barrier, the speed of light. If you say hello to Enceladus, it takes 3 hours to hear back from the spacecraft. So JPL is working on multiple innovations to get over these barriers. I'll just mention 2 of them. The first, robotic intelligence. That's my background. And we have made good progress on it. For example, the Perseverance rover to Mars. It can find a safe landing spot while going down to Mars. Or it can identify interesting scientific targets from images and shoot lasers to analyze the composition of the rocks. And this is what I developed, the autonomous driving on Mars. It can drive by itself, avoiding bugs. Versatile mobility. The rovers are mostly limited to relatively flat terrains, as opposed to us humans, right? We can run, jump, crawl, climb, even swim. We're working on robots that has wider range of mobility modes, like animals. And here's our new versatile intelligent robot called EELS. It can roll, it can slither, it can sidewind, it can move like a train on ice, sand, and snow, and it can even move up and down vertically between 2 ice walls. And it's highly intelligent. It can understand risks to make sensible decisions, in 3 weeks, we're going to actually bring the robot to Athabasca Glacier in Canada to test this robot in field. That'll be super exciting. So where can this robot go? We believe that eels can enable the access to the subsurface ocean of Enceladus by going down a crevasse that is likely connected to the subsurface ocean. Once in the ocean, you're going to sample the water, seek the signs of life. It finds life. That's going to be a discovery that is forever remembered by our remote descendants. But it's not just Enceladus, right? Once we overcome the next two barriers, pretty much everywhere in the solar system will become reachable. However, still, there are so many worlds in other star systems. Some might be inhabited, some might even host civilization. So what are the remaining barriers? The sixth barriers will be the lifetime of machines, right? Because interstellar travel is going to take thousands of years maybe. So we will probably need a robot with homeostasis which can repair itself, or probably it's an ecosystem robots that repairs each other or even reproduce and evolve. So now, imagine many thousands of years from now, this homeostatic ship of robots is going to finally arrive in a remote star system, make marvelous discoveries, and point its antenna to Earth to tell us about them. Are there anyone on Earth to listen to it? The seventh and the last barrier will be the lifetime of civilization. Can we sustain long enough to hear back from our interstellar spacecraft? I am not sure about it. And sometimes I think humans got a little bit arrogant, fooled by our own concepts. And the reality is that, we cannot even control the climate of our own planet, let alone others. So let's remember, we are going to other worlds not to occupy or colonize, but to humbly learn. We go far not to amplify our arrogance, but to become wiser. Let's first make sure that this civilization is going to prosper over non-negligible lifespan compared to the vastness of the space. And let's work together on the remaining barriers. There's no rush. Okay to take thousands of years. Someday, our remote descendants will get there and look back this pale blue dot and be amazed that the people in 21st century did not know things that are so plain to them. Many discoveries are reserved for the ages still to come, when the memory of us will have been effaced. Thank you so much.